Okay, we're going to go ahead and take a look at section 2 of unit 1. Now we're going to talk about some terminology to begin with. We have domain. Domain is typically the input values. If I can get this to work, sorry about this. There we go. Typically the input values, if you're dealing with an x and a y, it's typically your y values. Range is your output values, which you get out of a function, typically your y values. And then we also have a function. Something is a function if every number you put in gives you only one number out. Also, it needs to pass the vertical line test if you're looking at a graph. So that means a vertical line would cross it at most once. Now, down below, let's go ahead and talk about domain and range. Sorry about that. Domain. Now, remember, domain is your input, or typically the x values. When you're looking at an ordered pair, your x's are the numbers that come first. So when you're looking at ordered pairs, you just write down your x's as they show up. Can you put them from smallest to largest? Yes, but you don't need to. And then your range, now, your range up here is your y values. So you just have to write down your y values. So that's what we have. Now here we need to determine if these are functions. So remember, a function, every number you put in has only one number you get out. If you take 5 here and plug it in, you only get out -2. When you take 10 and plug it in, you only get out -2. It doesn't make a difference if the output's the same. It's just no matter what number you put in, you can only be paired with one number you get out. So that means this one is a function. When we look at the next one, we are taking 1 and plugging it in to get out a -5. But here it says we're also taking 1 and we're plugging it in and we get out a -5. So you plug one number in, which is 1, and you have two different outputs. So it says, your chart says you plug in 1 for your x's and you have two different outputs of -1 or -5. So this means no, it is not a function because 1 gives you two different outputs. When we look down below, I'm going to draw a vertical line because we have a graph. Will a vertical line cross your graph more than once? And yes, it will. So that means it is not a function. So over here on the right, we have a mapping diagram. So instead of giving it to you as in ordered pairs or a chart like above, we have it as a mapping. In other words, you take your 5, plug it in, you only get out one number here. You take your 10, plug it in, you get only one number here. You take your 15, plug it in, you get out only one number here. Doesn't make a difference if the output's the same, but each number you put in can only have one output. So this one is a function. Now, how would this not be a function? If I came along and I said 15 also gives me out 110. So here you'd see 15 has two arrows going from it, so it would have two different outputs. That means it would not be a function. So here we need to go ahead and graph these. Remember, when you're graphing, you can always make a T-chart if you want. But when we're looking at number 14 here, remember it's an equation of a line, y equals mx plus b. Remember, what is added to x is your y-intercept, so we're going to be starting at +1. And then the number in front of x is your slope, which is -2. Remember, our slope is rise over run, so I can go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, or I could have had a positive 2 over a negative 1, so that means I would go up 2, left 1, up 2, left 1. And then you just draw in a line going through all these points. And that would be your line. Now, looking at a graph, your domain is how far left and right your graph would go. This line goes up and down forever. So it would eventually go to the right forever, and it would eventually go to the left forever. Since you're going left and right forever, your domain is all real numbers. Now, range is how far it goes up and down. You can see that your line would eventually go down forever and eventually go up forever. Since it goes up and down forever, your domain is also all real numbers. Now, if you wanted, instead of writing out the words all real numbers, you could go A, R, N if you want. Then you have to decide, is it a function? So to decide if it's a function, especially if you're looking at a graph, remember you take a vertical line. Yeah, I take a vertical line here. Will a vertical line cross my graph ever more than once? And no matter where I put it, it crosses it at most once. So that means, yes, it is a function. Now, when we're graphing number 15 here, number 15 is not a line because it has an exponent of 2. And so I need to go ahead and make myself a table. And since it's not going to be a line, I need to choose lots of points. So I'm going to go ahead and try like -2, -1, 0, 1, 2, 3, 4, and 5. And then we just have to go ahead and plug these numbers in for x. In this case, we have x in 2 spots. So take 0, plug it in, we get 0. Take 1, plug it in, I get 1 minus 4, which is -3. I get plug in 2, I get 4 minus 8, which is -4. Plug in 3, I get 9 minus 12, which is -3. Plug in 0, I get 16 minus 16, which is 0. Plug in 5, I get 25 minus 20, which is 5. Plug in -1, I get -1 times -1 for the -1 squared would be a +1, and then it would be minus a -4, so it'd be 1 plus 4, which is 5. And then you could plug in your -2 and get that also, but we are going to be off our graph, so we'll just go with the points that we have here. When we look at our first point here, 1 to the left, up 5. 0 to the left, up 0. 1 to the right, down 3. 2 to the right, down 4. 3 to the right, down 3. 4 to the right, up 0. 5 to the right, up 5. And then you can go ahead and draw in your graph. So it's just a nice smooth curve going through all these points. Now, your domain. Your parabola, if you would extend it, would eventually go to the right forever and eventually go to the left forever. So your domain is, once again, all real numbers. Now, here, when we were looking at range, yes, it goes up forever, but it doesn't go down forever. So you need to look at it and say, how far down does it go? And range deals with y. It starts at a height of -4 and then goes up. So your range would be y is greater than or equal to -4 because it starts at a height of -4 and then goes up. So all your y values are larger than that. So then if you wanted to check to see if the function, you put in a vertical line and you move your vertical line across, and you'll notice your vertical line will never cross it more than once. So yes, it is a function. So here we're given a couple graphs. We're asked to identify domain and range. Now this is a line that goes left and right forever. So it means your domain would be all real numbers. You can see that your line would eventually go up and down forever, so your range is also all real numbers. When we're looking at problem number 23 here, we have the square root of x is equal to y. You can see it doesn't go left and right forever, but it does start here at 0 and go right forever. And so your domain is x is greater than or equal to 0. Remember, domain is x. Now, another way to look at it is x, y, which is alphabetical, domain, range. Notice domain and range is also alphabetical. So whatever comes first, x or y, or domain or range, go together. Now, when you're looking at your range, range is how far up and down. It starts at a height of 0, goes up forever. It would take a while to get there, so your range is y is greater than or equal to 0. Now we're going to look at evaluating functions. So we have function f. Now the rule for f says whatever you plug in, square it minus 3 times whatever you plug in. That's what it's saying, because x is your input here. So now if we're looking at, say, f of 5, which we want, 5 is your input, so that's got to go in for both of your inputs here. So when you work this out, 5 times 5 is 5 squared, minus 3 times 5, which is 15, and then we end up getting 10. When we are looking at function g over here, g says 3 times your input squared minus 4 times your input plus 5. That's what this rule right here is saying, where x is representing your input. And in this case, our input, when we're looking over here, is negative 3. So negative 3 has got to go in for all your inputs. Now, if you have a calculator, you should be able to type it in just as you see it with the parentheses all on one line and get the right answer. If you work it out step by step, you can still get the right answer. This would be 3 times negative 3 times negative 3 would be a positive 9. Negative 4 times negative 3 would be a positive 12 plus your 5. And so you get 27 plus 12 plus 5, which is 42. Now, that even works, this whole idea of writing out what this means, your input squared plus 3 times your input plus 2, and then whatever's in your parentheses is what you have to plug in for each one of these inputs. That even works if you're not just dealing with normal numbers, but even with stuff that has variables. So when we look at this here, it's a negative 5r times another negative 5r, which would be a positive 25. Remember, r times r is r squared. When we work out this right here, a positive 3 times a negative 5r would be a negative 15r. And then we just have to bring down that positive 2. So now, sometimes you'll have like terms. So you'd have things that are added or subtracted together that has the same variables with the same exponents. In this case, we don't, so there's nothing more we can do. When we are looking at f over here, our rule says 3 times your input plus 2. And then whatever's in your parentheses is what you have to go ahead and plug in for your x. So now we have some parentheses here. We need to just go ahead and distribute that 3 in. We get a 6m plus 3. Still with that black plus 2. You will notice our plus 3 and plus 2 are like terms. We could put those together. Our 6m is not. That's got an m. Well, we'll just bring that down. And so then that would be your answer. And then we got a couple of more problems to do. Same idea, but it should be relatively easy at this point. We have our input squared plus 3 times our input plus 2. And in this case, our input's A. Well, when we plug in A, it doesn't really change it a whole lot. So A squared plus 3 times A plus 2. So it's real similar to our original problem, but our input's A instead of our input being our X. When we write this out over here, it's 3 times your input squared plus 2 times your input minus 7. And in this case, we're plugging in triangles, so triangles got to go in for each one of your x's. So it's really 3 triangle squared plus 2 times triangle minus 7.